Hi, welcome to another 4AC learning video. In this video we want to look at example 4.2, which is found in your lecture notes, topic 4. For the circuit given below, we want to determine S, the apparent power. We want to determine P, the effective or average power. We want to determine Q, the reactive power, and also the power factor. Equation 31 refers to our lecture note, and then we want to compare the results we obtained in example 4.1 in an earlier video. So let's quickly visit what is equation 31. If we look back at the earlier part of this topic, you see that equation 31 refers to this formula whereby the power, the complex, when we put a theta there, we say it's a complex power, or we always call it apparent power. It can be computed based on the voltage and the complex conjugate of the current. What is the meaning of complex conjugate? It is the inverse of the current. Notice that the example given here, if I, the complex I is 3 plus J 4 amps or 5 amps angle 53.1 degrees, the conjugate of I is 3 minus J 4 amps or 5 amp angle, just the negative of the current angle, that's all. Right? So let's see how we apply this and whether we get a similar answer to that of the earlier example 4.1. Well, in 4.1 we got some of these calculations done, right? So in 4.2 we are looking at the same circuits, but now we apply a slightly different approach. That means we make use of the complex power formula. The complex power or the apparent power can be given as V as multiplied by the complex conjugate of the current. So you can write this as 100 angle 0 multiplied by 10. Instead of angle 53.13, I put a minus. So that gives me 1000 angle minus 53.13 degrees volt amps. Right? Convert this to the rectangular form. We will get okay, let's make a conversion. Shift rectangle 1000 angle minus 53.13. That gives me 600 minus J 800 VA. Now we compare this to our standard formula, is P minus JQ. Right? Minus means capacitive, right? Therefore from here we can deduce that P is 600 watt and Q is 800 VAR. Negative signs just say this is a lagging power factor. So power factor, we can get it from cosine of the phase angle difference, which is 0. Oh, sorry, not phase angle difference, the phase angle of the complex power, which is minus 53.13 degrees. So that gives me 0.6 leading. right, leading to the same answer as our earlier question. Right, comparing to what we used earlier. So this is another way of getting the same answer. Bye for now.